Hey, Math 30-1, how's it going? So we are going to do some, let's see what happened there. So do some confetti. So we are going to convert, or go over assignment number 1 here. So we're going to convert degrees into radians and radians into degrees. We're going to use exact values as much as possible. So to do that, remember, you kind of do the math without the pi, but then you put the pi back in. So I would set the ratio. You can memorize lots of different ways to do this. I like to just set up the ratio. And we're going to look for this. So I'm going to cross multiply, divide, solve for that question mark there. So the question mark in this case is going to be 270 times pi divided by 180. And then you reduce down the numbers. You kind of ignore the pi. And you get 3 over 2 pi. Right? If you want to change that into an approximate number, you can. You could actually just do the math. You go 3 times pi divided by 2. So you get the 4.71.
Campbell, can you phone into 263-210, please? 263-210.
All right. So I'm just going to go down all the degree ones here. Why not? So you're going to set up the similar kind of ratio. You'll reduce as much as possible. And we're going to leave these in exact values here. So 300 divided by 380. Math, enter, enter. So this would be 5 pi over 3. This one here, not going to go through the exact steps of this one, but it's going to be 490 divided by 180, sorry. Math, enter, enter. So this would be 11 pi over 4. Doing the same steps as the previous ones. This one here, we're going to change into, because all 3 of these are going to change into degrees. Remember, if you don't see anything, you assume it to be rads automatically if there's no degree symbol. So you could set up the ratio, but if it has the pi, you just have to remember that pi is 180. So I could just literally, in these kind of questions, replace the pi with 180. So 5 times 180 divided by 3. And I got 300 degrees. Hey, that's that same one that's over there. But it worked out. We got 300 degrees, and that was 300 degrees for C as well. Cool. Another way to do this one, you could set up the ratio. I'll put the degrees on the top this time because we're trying to find degrees. And then you put your question mark over top of the 5 pi over 3. You do a cross multiply divide. You could do it that way, just deal with the pi's. The pi's will reduce out. So you just times in the 5 over 3 to the other side. Okay. So that's how I would set up this one here, because there is no pi to replace with the 180. So I'm just going to put in my numbers like this, which I find degrees. I'm just going to cross multiply divide. I'm going to do the actual divide by pi. And I get negative 220, doesn't say, so let's say 229 degrees. I was looking for some indication of what kind of decimal place we need to do. There is a pi here, so I'll just replace the pi. And 13 times 180 divided by 4 is 585. Yeah, I'm starting to go insane. All right, so 585. Looking pretty good. Let's go down here. Let's identify one positive and one negative coterminal angle for each. Then we're going to write a general expression. So I want one of each, coterminal. So to find coterminal means you're either going to plus 360 or 2 pi, because those are the same thing, or minus those two. And we're going to try to keep these in exact values. So remember, when we're dealing with this, both have a pi in them. You just factor the pi out and just add the coefficients together. So 11 over 6 plus 2, math, enter, enter. This ends up being 23 pi over 6. And then I'm going to go 11 over 6 minus 2, math, enter, enter. And I get negative pi over 6. I'm just going to move this downward just a little bit. I'm going to show you the work for this one. So I factor the pi out, and then I go 11 over 6 minus 2. 11 over 6 minus 2 is 1/6. Actually, negative 1/6 here. So that's where we get the negative pi over 6 from. Okay, so we got the two coterminal angles, one positive, one negative. Then we're going to set up a general expression for every single possible coterminal angle. So we're going to start off with the smallest principal angle, which was 11 pi over 6. I'm going to add 2 pi as many times as I want, so we'll put a little n in there, NEI, which means I can add or subtract because I could be a negative or a positive number. For these ones, you'd add 360. Okay, if I add 360, now you're going to see what happens when I add 360. It's not going to be a positive number because I want one positive, one negative coterminal angle. So one negative coterminal angle is negative 15 degrees. Okay, so now the thing is I'm going to have to add another 360 to this. So add another 360, I get a positive number. So this will be my first positive coterminal angle. So my two angles, I got negative 15 degrees and 345 degrees. If you want, you can go even further back in the negatives. You subtract and 360 from that and get another angle. So my first positive coterminal angle, principal one right here, is going to, well, if I'm going to write my general expression, I'm going to use that one. And then I'm going to times by 360n, NEI. Perfect. So these are the two things we're looking for. We're looking at that, and we're looking for this one, right? We're looking for these two answers, and we're looking for this guy here. All right. Determine the measure of the central angle subtended by each arc to 1 decimal place. Yeah, so we're looking for the angle. So we pull out our formula sheet, if we had a formula sheet, and it would say arc length is equal to r theta. R is the radius and theta is the angle in radians. So I'm going to rearrange this formula, A over R, and then I get 31.4 centimeters divided by the radius of 5 centimeters. So I can figure out that the subtended angle is 6.28 rads or radians. Almost a complete circle. Yeah, cool. Because 2 pi r, yeah, that makes sense. It's almost one complete circle. Not exactly a complete circle because remember, pi is a non-repeating decimal. Okay. This one here, they want it in degrees this time. Like, okay, how do I find these degrees? You always get radians when you, this formula, this is always going to be in radians. Well, it means it's going to be a two-step process. So it's going to be A over R, 11.3 divided by 22.6. And I'm going to get 0.5 radians. So not 0.5 degrees, but 0.5 radians. Then we just do similar stuff that we did in the first question there. We set up a ratio. We solve for that. Nice little question mark there. So 0.5 times 180 divided by pi. And we get an angle of 20 to the nearest 1 decimal place. Okay, so, oh, so 1 decimal place. Then maybe I should do this 1 decimal place then. Okay. 28.6 degrees. Very important that you put the degree symbol there. right? You didn't put that there, then I would think it's rads and mark you wrong. Yeah, this is a pretty short one here, so let's keep on going. Determine the missing coordinate for point P. If this lands on the unit circle, okay, so if it lands on the unit circle, that means it has to obey this equation, right? X squared plus y squared is equal to 1 squared. Then what we're going to do is we're just going to rearrange this for x. I'm going to leave the x squared there for now. I'm going to put in the y coordinate. I don't know why I have this little picture. You can draw it if you want to. All right, and I'm going to 1 minus 2 over 3 squared. Can I go math and turn here? Yeah, I can. Okay, so this ends up being 5 over 9. Let's leave this as exact answers as possible. So I'll take the square root of 5 over 9. Ooh, okay, this could either be, oh, it has to be in quadrant 3. Okay, if it's in quadrant 3, so that means it's down here. That means my x value has to be a negative number, right? Because remember, when you take the square root, you get positive or negative. But because they're telling you it has to be in quadrant 3, my x is going to be a negative root 5 over 3. So I take the square root of the top, square root of the bottom. The 3 pops out. And then we get that number. That's pretty good. Okay. Determine the value of theta in standard position. Yeah, okay. Doesn't seem too bad. A few different ways to do this. These are unit circle numbers. I don't know if we talked about the unit circle. Is that the next lesson? It might be this lesson. I can't remember, but that doesn't really matter. So this is essentially just unit circle stuff. Where does this point land? So this point lands positive 1/2, positive root 3 over 2, so somewhere right about here. Root 3 over 2 is larger, so this triangle would look more or less like this, where this angle in here is going to be 60 degrees. And I know it's 60 degrees because that is opposite. The opposite side is the longer side, so this has to be the bigger angle between the 60 and the 30. And I've seen root 3 over 2 before. If I put this into rads, this is going to be pi over 3. It's going to be 180 divided by 60. Math, enter, enter. Yeah, or the other way around, 60 divided by 180, sorry. Math, enter, enter. 1 over 3. There you go. You really don't have to do too much other than just that angle. Oh, in standard position. Because it isn't the first quadrant, this is the standard position angle. Remember, the standard position angles measured from the x-axis counterclockwise to that one. So that is the same as the reference angle. Right? I'm going to put that in here. It just happens to be the same one. Okay. This next one here, we're going to put this one, this point. It's positive x, negative y, so right about here. These two sides are the same, so this is the 45 triangle. Plus, I recognize those numbers as the 45 numbers. So my reference angle is 45 degrees. Okay? You can also just do like a tan inverse if you wanted to. But we're not looking for the reference angle, we're looking for the standard position angle. So we want this going all the way around. So this will be 360 minus 45, or because this should be in radians, 2 pi minus pi over 4. I should put that in radians. And I could do that math. 2 minus a quarter. 7 pi over 4. If you did, you get 315. And then you can change it. Oh, that's a really weird arrow. And you can change that into radians if you want to. I think you have to because the question says so. Yeah, 0 to 2 pi. So you want all your answers to be in radians. It's very important. Okay, hopefully that answers a bunch of questions for that one. Hopefully you did well, and I'll see you in the next video. Bye.